Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the video to solve a bonus problem similar to this one. So we have x to the power of 3 is equal to 8. And this equation actually has two solutions. I know a lot of you out there probably think that this equation only has one solution, but you're actually wrong. So to solve this problem, I'm going to first subtract both sides by 8. So now I have x to the power of 3 minus 8 is equal to 0. Now 8 is the same as 2 to the power of 3. So now I have x to the power of 3 minus 2 to the power of 3 is equal to 0. Now an important property in algebra is that if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So right here we have x to the power of 3 minus 2 to the power of 3. We can think of x as a and 2 as b in this case. So now this will give us x minus 2 times x squared plus 2x plus 2 squared. Now this is equal to 0 still. And now this gives us two equations. I have x minus 2 is equal to 0, and I have x squared plus 2x plus 2 squared is 4 is equal to 0. Now first, for x minus 2 equals 0, I can simply add 2 on both sides, and I would get x is equal to 2. And this is probably the solution that everyone thinks this equation has, but there is actually one more solution. So we have x squared plus 2x plus 4. And to solve this, I'm going to factor, or I'm not going to factor, sorry. I'm going to use the quadratic formula to find the solution to this equation. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now, the coefficient in front of x is 1, the coefficient in front of the coefficient for x squared is 1, the coefficient in front of x is 2, and we have 4. So a is equal to 1, b is equal to 2, and c is equal to 4. So now if I plug this into the quadratic formula, I get negative 2 plus or minus the square root of b squared, which is 2 squared, minus 4 times a, which is 1, times c, which is 4. And I am dividing this with 2 times a, which is 2 times 1. So now this is equal to negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 is 4, 4 times 4 is 16, divided by 2. 2 times 1 is 2. Now this is equal to negative 2 plus or minus the square root of 4 minus 16 is negative 12 divided by 2. Now the square root of negative 12, I know that a lot of you out there think that the square root of negative numbers is not possible, but that's where I comes in. Now this is equal to the square root of negative 1. So the square root of negative 12, well, 12, this is equal to 4 times negative 3. And the square root of 4 is 2. So I have 2 times the square root of negative 3. Now remember how I was the square root of negative 1, so this was equal to 2 times the square root of 3 times the square root of I. or sorry, not the square root of I, it's just I. So now I have negative 2 plus or minus the 2 times the square root of 3i. And we are dividing this by 2. Now 2 can divide with both of these terms. So now I have negative 2 divided by 2, which is negative 1, plus or minus 2 divided by 2, which is simply just 1, times the square root of 3i. And this is equal to negative 1 plus or minus 1 times the square root of 3i is simply just square root of 3i. And this gives me two solutions. I have negative 1 plus the square root of 3i, and I have negative 1 minus the square root of 3i. So my three solutions are 2, negative 1 plus the square root of 3i, and negative 1 minus the square root of 3i. So we have 32 to the power of x is equal to 4. And make sure to stay to the end of the video where I have a bonus problem similar to this, which you guys can try to solve. So 32, this is actually equal to 2 to the power of 5. So now I can rewrite 32 to the power of x by substituting in 2 to the power of 5 for 32. So now I have 2 to the power of 5 to the power of x is equal to, now 4, this is equal to 2 squared. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, for 2 to the power of 5 to the power of x, a would equal 2, m would equal 5, and n would equal x. So if I put it in the form a to the power of m times n, I get 2 to the power of 5 times x, which is equal to 2 to the power of 5x. So now I have 2 to the power of 5x is equal to 2 squared. And if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So for 2 to the power of 5x is 2 squared, these two exponents would be equal to each other. So I have 5x is equal to 2. Now we want to isolate x, so I'll divide both sides by 5. These two cancel out, and I get x is equal to 2 over 5. Now we can go ahead and plug this into our original equation, 32 to the power of x equals 4, and see if it's right. So if I plug in x as 2 over 5, I get 32 to the power of 2 over 5 is equal to 4. Now, 32 to the power of 2 over 5, this is the same thing as 32 to the power of 1 over 5 squared. Now 32 to the power of 1 over 5, this is the same thing as the fifth root of 32 squared. And the fifth root of 32 is simply 2. So I have 2 squared. 2 squared is equal to 4. So I have 4 is equal to 4. Because this is true, we know our solution is true. Now, another simpler way of doing this to solve this problem is to take the log on both sides. So I have log 32 to the power of x is equal to log 4. And an important property of logarithms is that if I have something in the form log a to the power of b, this is equal to, I can actually move this exponent to the front of the logarithm, so this is equal to log b times log a. So now I'm going to do this with log 32 to the power of x. I'm going to move my exponent x to the front, so this is going to equal x times log 32. So now I have x times log 32 is equal to log 4. Now I can divide both sides by log 32. So now I get x is equal to log 4 over log 32. Now 4 here, this is the same thing as 2 squared. And 32, this is the same thing as 2 to the power 5. And now remember, if we have something in the form log a to the power b, this is equal to b times log a. So for both of these, I'm going to move the exponent to the front of the logarithm. So now I have x is equal to 2 times log 2 over 5 times log 2. Now these two log 2's can simply cancel out, so I end up with x is equal to 2 over 5. So as you can see, we have the same answer, but we use two different methods. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 25 to the power of x is equal to 125. Now, when we're solving problems such as these ones, and we're using exponents, we always want to make the bases of these two terms the same. As you can see here, the bases of these two terms right now are 25 and 125, which aren't the same. So we need to change these two terms so that they have the same base. Well, what's a common base for these two terms? 5, because 25 is equal to 5 squared, and 125 is equal to 5 to the power of 3. So if we plug these values in for our numbers here, both our bases would be 5. So now we have 5 squared to the power of x is equal to 5 to the power of 3. Now, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 5 to the power of 2 to the power of x, this is going to equal 5 to the power of 2 times x, which is simply equal to 5 to the power of 2x. So now we have 5 to the power of 2x is equal to 5 to the power of 3. And if we have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So right here, we have 5 to the power of 2x equals 5 to the power of 3. This means that 2x is equal to 3. Now, this is a simple equation. All I have to do is isolate x, so I'm going to divide both sides by 2. These two cancel out, and I get x is equal to 3 over 2. So this is our answer.